Hi everyone, we will move on the flip-flop next section, some conversion of the flip-flop. Usually, we know that how particular flip-flop is working, SR or JK, TRD, how we can convert one flip-flop and it act as another type. Suppose, if you take one example, we have to make such a way that the JK flip-flop can be converted into the form of T flip-flop. So, how we can do this operation? So, first our aim is to make something work as a T flip-flop, but we have to use JK flip-flop. So, I have to use JK, but it not act as a JK, it actually act as a T flip-flop. That is the aim. So, to conversion first, I have to check what is the working of T flip-flop. So, I will go with the T operations. There is a possibility that the previous input is 0 and T is 0. We know that when T is 0, T is same as the previous, so we will get 0. If you take previous input is 0 and if T is 1, so T is 1 means it is interchange of Q, so next output become 1. Similar way, if previous input is 1 and T is 0, there is no change in the input, so 1 only. And if T is 1, previous input is 1, it will toggle, so it become 0. This is what next state of the flip-flop. Now, we will check with the JK flip-flop because our aim is to convert from JK to T. So, here we will write whichever we have to taking from. So, JK, how it actually work for that. So, here our aim is the previous is 0 and next state is 0, 0. So, to making previous input 0, next output 0, what is the JK condition we have to take? This table whatever we have taken, this is called excitation table. Previously we are discussed on this. So in this excitation table for JK and SR I have taken as a reference and T and D is easy. So for those reference I have not taken. Now if you make 0 to 0 conversion, usually we have 0 don't care in JK. So take that option 0 don't. When you changing from second part 0 to 1. So, the previous is 0, next state is 1. 0 to 1 state, we are taking 1 don't care. So, JK, we have to take 1 don't care. Similar way, next state, it is sending from 1 to 1. Previous state is don't care and 1, so take that value. So, excitation table, last part we have discussed, excitation table and state diagram. So, that we are taking as a reference here. From that reference, we are made such a way that first we are written which we have to convert that flip-flop and then what possibility of JK we have to take that one. So now we have here J and K. First we can make for output for J what is the truth table. J is something like 0, 1 don't care, don't care. So when 0, 0 it is 0, when 0, 1 it is 1, when 1, 0 it is don't care and 1, 1 it is don't care. You can take such a way that here the Q previous and here you have to take T flip-flop. So in this condition we can make grouping is such a way that 1 and don't care and it is both the row is selected. So this is called as a J is equal to Q. So because T is 1 here in this portion, so we can take as a T and Q is get cancelled because of both 0 and 1 consists. So we can say that from this rule J is equal to T. Similar way we can go for the K option. So when you going for K, we have the option here don't care 0, 1. So first don't care because of this is the Q portion, this is K portion. So this is the T portion. So when 0, 0 and 0, 1 it is don't care. Next 1, 0, 1, 1 it is 0, 1. So take that value 0, 1. So it is similar to the previous operation. So K also is equal to T. Already we know that this formula, that means J and K, if you short I will get T. That is we have proved with this method. So we can say that if you want to convert JK as a T, so you have to take T is equal to J. So T is connected to J. Similar way, T is connected to K also because K is equal to T. This is the very simple way to make any flip-flop conversion to the other flip-flop. Some like that example, we will check what happens to these conversion of flip-flops. Now we can check with the another example how SR flip-flop can be converted into the T flip-flop. So we can make that SR flip-flop to T flip-flop. So in the first step, we have to make such a way that truth table something with the which conversion we have to do. So go with the T flip-flop as usual previous and fill this table. So when previous is 0, present is 0. So T is portion 0. So it is remains same. So T is 0 here remains same. T is 1 opposite to this one. So 1 here T is 1 opposite to this one. So 0. So this is how we are taken from previous only. Now we can convert to SR. So take SR excitation table. In SR excitation it says the first portion here it is converting 0 to 0. So it is 0 don't care from this table here when it is converting 0 to 0. Similar way fill with other part. When it is converting to 0 to 1 we can take as a 1 0, and when it is going to the 1 1 so it is don't care 0, and the last condition 1 to 0. So 1 to 0 is this condition. So here 0 1. This is what SR flip-flop comes. Now first our aim is to convert into the flip-flop. First you have to find the equation of the S. So S here 0 1 don't care 0. Before that take the input like Q and T. Similar way here also for Q and T. So when Q is 0 and T is 0, this condition the S is 0, take that. Then next condition when Q is 0, T is 1, this condition S is 1, so 0 1 is 1. Similar way don't care and 0. So here I cannot make group, so single one I can take it. When you take this one, your formula become here Q bar has to be present and T. So this is the formula for finding S. Similar way go for R. So R is present, don't care 0 0 1. So don't care 0 in the first part and then 0 and 1. So here also it is group of 1 only. So if you take this one, 1 means Q. So here 1 means it is T. So R is equal to Q into T. So according to this you have to do, our aim is to convert SR flip-flop. So write first SR flip-flop here. Then we have to take input as a T. Now what else you have to do? For S it is T Q bar. So you have to take from something from Q bar. So take here Q bar and take from T. So we have T and Q bar. It is multiply. So you have to use NAND gate and connect it to the S. So this is T Q bar is equal to S. Similar way we can do for R is equal to QT. So take from the Q here to the R condition and T we have to take from here. So these two are AND gated and connected to R. From this diagram we can say that S is equal to T into Q bar, and where this particular portion of R is T into Q. So this is the method how you convert one flip-flop to another flip-flop. Next we can take one more example how the JK flip-flop can be converted into the D flip-flop. So here the main portion of the flip-flop we are using JK, but it has to be act as a D flip-flop. This operation already we know that how to we are made JK to D, but we can prove with this method. So first take here input as a D, and in this case what happens when the D0 it is not bother about previous value, so we usually not taking the previous value of the when D flip-flop. So just copy down whatever here, when 0 it is 0, when 1 it is 1, when 0 it is 0, when 1 it is 1. So this is how the D flip-flop table comes. Now for this conversion we required previous, when it is going to the 0 to 0, what exactly JK flip-flop work like. So JK is work like 0 to 0. It is nothing but 0 don't care. So copy down that, and then it is going 0 to 1, nothing but 1 don't care, and it is going to 1 0. So it is don't care 1, and then it is going 1 to 1. So it is nothing but don't care 0. So nothing but how the previous to next output it is changing. That relation we have to go with the JK flip-flop. Now take K-map for the JK flip-flop. So first check J. It is nothing but we have to take in this portion. The Q is here and D flip-flop in this side. So 0 1 don't care don't care. So take 0 1 don't care don't care. So this is the one group. In this group you can say that we are taking with the J flip-flop. So J is equal to this condition Q is cancel out. So this condition is D. So J is equal to D we got. Similar way you can go with the this second one for the particular part of the K flip-flop. So K we have don't care and don't care. So take for don't care 1 0. So we can make grouping of something like this. In this grouping the Q is anyway get cancelled, but the K is equal to D0 is nothing but KD bar. So we have to draw the diagram. First take whichever input we require. D flip-flop means D. So J is equal to D. So simply short it here. Then the K and D relation is D bar. So go with here and NOT gate and make it this. This is nothing but how you convert JK flip-flop to D flip-flop. Next problem, we will try one more, something like D flip-flop to T flip-flop. So, how we can convert particular data flip-flop to toggle flip-flop. Here, our aim is, this is D flip-flop and the input we are taken from T, but how to connect T to D, the relation. So, this portion, usually second portion not required. For this, first you have to write what is T flip-flop relation. So, T flip-flop relation is when the 0, we know that it is same as previous. So whenever 0 condition take previous value, whenever 1 condition Q you have to take Q bar. So 0 become 1 and 1 becomes 0 here. So the relation to D flip-flop. Here the very simple to D flip-flop, because the D flip-flop relation is always whatever input is equal to output. So input is here 0. So output also it should be 0, and our relation is D is always equal to output to input. Here we take D as an input and Q T plus 1 is equal to output. Both are is equal to. So simply you can copy down 0 1 1 0. This is nothing but excitation table of the D flip-flop. If you are doubt with this, go to check with the excitation table of D flip-flop how we made and what is the output we got. So from this we are taken as a 0 1 1 0. In that we have to make as a portion. So here if you take for D flip-flop output, so we have this portion is Q and this portion is T. It is 0 1 1 0. So 0 1 1 0. This is what we got from the truth table. From this we can say that there is no grouping possible. So we have two groupings. And one is nothing but in this Q is 0 and the T portion is 1, so it is Q bar T plus in this case the particular portion 1 is equal to Q and another condition T is equal to bar, so QT bar. We know that if it is any relation something like that Q bar T and QT bar is nothing but A bar B plus AB bar, we can directly take this one as a XR. So Q XR T. So we have to take from output Q portion here, take Q here, and you have to take from T. So Q and T we have to make it as a something like XR operation. So this is how it look like. This is the output for the D flip-flop. So here we are giving Q and anyway T is given. So these two are XR. So getting to the T. This is how D flip-flop can be converted into the T flip-flop. Next we will discuss on opposite version. So T flip-flop can be converted into the D flip-flop. How it is possible? So what are the things we have to change it here? Our aim is to, it is the T flip-flop. So it acts as a D flip-flop. So take D as a input. So first here how D flip-flop is work. We know that if it is a D input is 0, it is 0 only, 1 means 1, 0 means 0, 1 means 1. It is not bothering about the previous output. Now converting to the T excitation table, here if it is 0 to 0 conversion, it is no change, so T flip-flop is 0. If it is 0 to 1, it is changing, so T flip-flop is 1. If it is 1 to 0, it is changing, so T flip-flop is 1. 1 to 1, no change, so T flip-flop is 0. This is how T flip-flop look like. So take as a T flip-flop for T as an answer. For this we have to take as a Q versus D. So when 0 0 it is 0, when it is 0 1 it is 1, when 1 0 it is 1, and 1 1 it is 0. It is exactly same as previous what we are completed. This grouping exactly we get as a previous one. First one you take this one. In this condition we have Q bar and D is there, and this condition we have something like 1 is there in the Q, so Q1 and D bar. So it is similar of previous operation, so we can take directly Q XR D. So take Q from this side, and we know that D is we are taking from here, and XR make it and connect it to T. So when you are making T to D or D to T, simply make as a previous output as a XR, you will get the answer. This is the what method we are used to make all those stuff. There are a many possibility of conversion of one flip-flop to another flip-flop possible. Whatever easy part only I have done in this video. If you have any doubt in the particular flip-flop conversion, you can put in the comment. I will explain that one.